Hi, everyone. How are you doing tonight? My name is Megan Dwyer. I'm an AP Calculus teacher, and I'm here tonight to review the existence theorems with you. And we'll also review what's on the exam right now, what's changed, and we will review, if we have time, the squeeze theorem. I also added that in since that was one other theorem that may possibly appear on the exam. So I'm going to go and make my PowerPoint full screen so you can see that better. Hi, thanks everyone for coming tonight. If you haven't seen the chat, feel free to use the chat anytime to answer my questions or to let me know if you have questions. I'll be asking questions throughout it. All right. Okay, so just another reminder, as I do with every stream, we have different streams that air different nights of the week. So Mondays, we've got 4 different ones. Tuesdays and Wednesdays, there's 3 different exam streams, and then on Thursdays there's 2. So feel free, if you're in more than one AP class, log in as many times as you want, come to as many streams as you can, and these are recorded and put on our website after. So if you can't attend, make sure to look them up after. And then if you're interested in when these streams are happening, there is we have social media, obviously, so Twitter, Instagram, YouTube. Look at Think Fiveable, and you'll be able to find us and find out what the topics are for your streams and what the new streams are coming up. Okay, so I'm going to start right now with a review of what's happening on the AP exam that has changed so far. So hopefully you guys have looked this up or heard a little bit about this by looking at the AP website and clicking on the coronavirus update. But there is going to be 2 free response questions. One that's 25 minutes and one that's 15 minutes. In between each, you will have 5 minutes to submit each assignment. You can submit a picture on a paper, or you can you can write it on a paper and take a picture and submit it, or you can type it on your computer and submit it that way. The exam date is May 12th at 2 p.m. Eastern time, our time. And the makeup date is later on, but you need to take it this date unless your school that you're at says the makeup date is okay. And another interesting thing is that it's going to be calculator optional. So in the description that AP gave, they said that you do not need a calculator in order to take this exam. You're allowed to use one. It is, but it's not something that's going to be, like, if you don't have one, it won't hurt you. There will be on your computer or whatever device you're using a 4-function calculator, and they do say that those are necessary. They did not tell us, good question, Courtney, thank you. They didn't tell us how many parts there are to the FRQ questions. They just told us that there are 2. I'm guessing that the 15-minute one will have 4 parts, like our usual 15-minute one does, but that the 25-minute one will probably have more than that. We've never had a 25-minute question before on the AP exam, so this is going to be a change for us. Some of the other APs have 25-minute questions, but my guess is it's going to be maybe 2 more parts than an original question, so maybe A through F instead of A through D. Do you guys have any other questions? Yeah, it could be 6 or 7 parts. Any other questions on the setup of the exam or the type? That's a good question. How many points per part? They did not tell us how many points per part. Yes, you can use a TI-84. Oh, 60%. Okay, so someone's seen it. Actually, yes, you're right. 60% for response question 1. I do remember seeing that now. 40% for response question 2. Thank you, Akshita. So yeah, that's the breakdown. I know students in my class were worried. They were like, well, what if I get question 1 wrong? Just be aware that AP is looking into your questions, and the partial credit, just like on any free response question, is always available. So no matter what, even if you maybe calculated something wrong in the first part, as long as you're doing the right steps in the second part, you can definitely earn partial credit. So it's not like you're going to get all of free response question 1 wrong. You definitely have wiggle room there. AP also told us that they have talked to many colleges across America who have promised and said that they will be taking this credit 4 or 5, 3, 4 or 5, like they always have. Yeah, no, you can use any calculator, but they said that a 4-function calculator is all you would need. So there will be, you can use any calculator you want, but you do not need a graphing calculator. The AP is working on kind of basically making questions that have never been seen on the internet and that aren't easy to look up, and that people with or without a calculator, they wouldn't have an advantage. An advantage of having a calculator you're comfortable with is definitely better. But yeah. So it will probably be different topics under one question or different units. You could definitely have some questions with a derivative and some with integrals under the same problem. So yeah, you should be ready for any unit within each question. And yeah, another thing, if you haven't heard yet, unit 8 is taken out. So for calculus AB, it's units 1 through 7. Unit 8 is average old APs as practice. Absolutely, I would recommend doing old APs as practice. But the average integral, the cross sections, any kind of rotations around axes for discs or washers, that's all been taken out of the AB exam. The BC exam has all of polar and parametric coordinates taken out. And so that's unit 9, all of unit 9. And then unit 10 just has a few sections in it on geometric series, harmonic and P-series, alternating series and ratio tests for convergence, and writing a Taylor polynomial. So that's it for AB. Yes, U substitution will still be on the test. I think I missed one question up here. I don't think so. Perla, your question about will online integral and derivative calculators give people an advantage? I think AP is accounting for that. Those are online and that people have those as resources. So I am hoping that no, they won't give people an advantage in any way. AP is really doing their best to make sure that this test really doesn't have problems that you can just calculate online and not have to show any work for. And if someone does use an online integral calculator, it doesn't show any work, they're not going to get full credit anyway. You need to show out all the steps to make sure that you get full credit. Yes, absolutely. Honestly, what I would do right now to prepare is to look up all the free response questions for previous tests are available on the AP website, and I would and their solutions, and I would look those up. And I would use every free response question from past tests and trying those. I would focus on the non-calculator section ones because those are the ones that will be on the exam because there won't be any that require a calculator, but you should still try the calculator ones because there will be good topics on that too. I would say in general, there will be parts of the problems that are application based. Yes, it's all word problems. It's going to be all word problems. And I would say studying mostly free response questions is really where you need to go. But some parts of free response questions are just like remembering to use product or chain rule. We're actually going to see that today in an example I have with the existence theorems. Yeah, it's just those 2 word problems. Any other questions? Okay, awesome. You guys have asked great questions so far. If you have questions come up, feel free to ask them at any point. I will be checking this as we go. I'll move on to our agenda for today. So we're going to talk about the existence theorems. That's the intermediate value theorem, the extreme value theorem, and the mean value theorem. We're going to talk about all 3 of those. We're going to do some example problems and how to tell the difference between when to use each of them and what is important to know. And then if we have time, we're going to practice the squeeze theorem after that. And that's just kind of like a little extra add-on. That is not considered an existence theorem. Okay, so let's look. Okay, so why are they called existence theorems? Had a nice meme there for you. I thought you'd enjoy. The squeeze theorem is not an existence theorem, but it is a theorem from unit 1. So we're going to practice it tonight. I thought if we had time, we'd squeeze in the squeeze theorem. But before past the squeeze theorem right now, thank you, Perla. Why are they called the existence theorems? Why are these three theorems called the existence theorems? I appreciate the support. I'm doing my best to make calculus fun. You're on the right track, Perla. So we're talking about existing. Yes. Okay. Yes, they show if something exists. All of them show if something exists. And it often is talking about an X or Y value in some interval that you're looking at. Yes, so we've got these conditions we're going to have to meet for each of them. And if we meet those conditions, then it guarantees this other thing exists. So all of these theorems help us based on what we have started with to tell us something about what else we need to know. Okay. So we're going to start off, and we'll start with the Intermediate Value Theorem. This one, there's only one condition here, and that is that f has to be continuous on a closed interval AB. Okay, and what this theorem says is that if there's any number, let's call it k, that's between f of a and f of b. Okay, so k is a y value. K is a y value, and basically what it's saying is that if k is between the other two y values, then k must have an x value that's between the other two x values. Okay, so an important distinction here is that we're starting with y values. This theorem doesn't go the other way. It doesn't say that if you have a certain x value, it definitely has a y value that maps. It's saying if you have a y value that's in between two other y values, then that its x value must be in between two other x values. Are there any questions on any parts of that theorem that you're unsure about? Some of you might be thinking, well, that seems like obvious, but it's actually really a powerful thing to be able to not have to like prove every time that if this point's here, this one's in between the x's. Basically the easiest way to be tricked by this question is to not realize you have to use it. So most of the time they won't tell you to use the intermediate value theorem, and you won't prove something fully, and you won't end up getting full credit for it, where if you had just said by the intermediate value theorem, this has to be true. So really it's about knowing when to state the theorem. And this is most commonly used in free response questions by saying something like, prove that there is this point X that's between A and B. And so you're probably given some Y values, and you have to say, well, since this Y value is between these, by the intermediate value theorem, it's between these. So yes, I would always suggest stating the full theorem when you're applying it, or you can call it the IVT. As long as you write IVT, they'll know you mean intermediate value theorem. I think if you completely described the theorem, AP would give you full credit, but it's always safe to write the theorem. There have been questions where they've taken credit off if you didn't write out the full theorem. No, I don't think you have to write out intermediate value theorem, but again, as long as you're writing IVT, they know that means intermediate value theorem. But if you have time to write out intermediate value theorem, it might be smarter to. Again, AP, this test is a little bit different, and they might be looking for more detail in terms of how you're describing everything, but not too much. It seems like they're keeping the same rules. Another thing to note, I don't know if you guys have read this on the website, but that you still can leave answers unsimplified. So if you've plugged in all of the values that you have and you are just left with some arithmetic you have to do, you are perfectly allowed to just leave that as is and move on to the next part. AP really actually encourages you to do this because they don't want you messing up in the arithmetic part when you've done all the calculus right. Do you need to add a reason? No. So that's the great thing about the intermediate value theorem and all of these theorems is that once you state that you've used the intermediate value theorem and you've stated its conditions, then you can just say, by the intermediate value theorem, this is true. Yes, we will do an example. So I'm going to go through all three of the theorems, and then I'm going to go through how to tell which one to use. And then we're going to do a free response question from an old AP test that'll show you how to use these. Okay, so I'm going to move on to the next theorem for now. But there's a reason I underlined continuous. So remember the condition for this one, and that's really the important part here, is the condition is that this has to be continuous or you cannot use the intermediate value theorem. Okay. Next, we have the extreme value theorem. So if a function is continuous on a finite closed interval, so you need a function that is not broken anywhere, does not have any discontinuities in any way, and it's on a closed interval that ends at both ends, then on F, there exists both an absolute maximum and an absolute minimum. So this is saying if you can see the whole graph, then there has to be a part on that graph where the graph is the highest it's ever been and where the graph is the lowest it's ever been. If you're looking for a point like that, let's just get into some application. If you're looking for a point like an absolute max or min, what kind of points do you need to test to find the absolute max or min? Endpoints, good. What else? There's one more type of point, critical points. They're good, awesome. You guys are great tonight. A lot of participation. I'm loving it. So there was a question there. Can there be multiple absolute max and mins? No, there can be multiple relative max or mins, but there cannot be multiple absolute max or mins. So if it's absolute, it's saying this is the highest point. The only place where that gets a little tricky is say you have a constant line or a constant graph that you're looking at, then that means that your absolute max and your absolute min are the exact same point because you haven't gone up or down. But there is still only one of each technically because there's not two different values that would work for it. So a sign graph would have to give you a finite closed interval. That's the problem. So it needs to be continuous, but it also needs that finite closed interval. So that even if it reaches the same y value both times, then that's still one value that is technically considered the maximum. I guess technically you could have two x values that display the maximum value, but there hasn't really been an AP question that would ask anything like that. Yes, Anika, so I'm going to address Anika's question right now. Do we need to say since the function is continuous? You absolutely do. That's a really important part for AP is you need to make sure you've proven that the function is continuous. Sometimes it just tells you, yes, you can only have one absolute maximum y value. So yeah, the function, you have to prove that it's continuous or you have to state that it's continuous if they've already told you. One thing to make sure is that if they say it's differentiable, then you already know it's continuous. Okay, and then last but definitely not least, we already went over this part. So just to review again, how to find absolute extrema, you find the critical points and the endpoints, you evaluate all of them according to the function, and then whichever one is the highest is the absolute maximum, whatever one's the lowest is the absolute minimum. So these slides will be updated into Fiveable with this presentation. So you'll have the presentation, access to it, and you'll also have access to the slides. Okay. Yeah. Okay. So the mean value theorem, like I was saying, last but not least. So this one's a little different because not only does F have to be continuous, but F has to be differentiable. You need to prove that both of those things are true in order to be able to know that you can use the mean value theorem. Okay, and the mean value theorem says one specific thing. It says that if you have a secant line and an average slope between them, if this function is continuous and differentiable, then there's also a point C where if you drew a tangent line on it for its derivative, you'd have the same value. Yes, you might need to take the derivative in this case. We'll see that in a couple examples later on. Okay, so this one, the difference between this is the only theorem that you have to prove it's differentiable, but it's also the only theorem that involves a derivative. The other two didn't involve a derivative at all. So if you know something's differentiable and if it's asking something about its derivative, to prove differentiability, most of the time they will tell you instead of having to prove it. But usually what you do to prove differentiability is as long as you don't, if you're looking at a graph, as long as you don't have a corner or a cusp or anything, it's differentiable. If you're looking at an equation, if it's a polynomial, it's already differentiable. In any other type of function, like for example, maybe a piecewise function, if it's a piecewise function, you might want to use the limit definition of a derivative and show that the limit as h approaches 0 from the left is equal to the limit as h approaches 0 from the right of the definition of a derivative. So basically you're saying that at that point, the slope from both sides is coming to the same slope. So that's why when you have something like the absolute value function, or in this case, the negative absolute value function, these slopes are so different that when they meet, you can't say there's one slope happening at their meeting point. So that's how we say this isn't differentiable, because this slope is positive, this slope is negative. So there's no way to say what's going on at that one specific point. Okay, so that's exactly what we're going to be doing next. So there's a couple questions here. Let me just make sure I catch on to those. Okay, so yeah, you need to meet the continuous and differentiable conditions, and then you can use the formula. So you might have to use it in different ways, and we'll talk about that. But yeah, that's good for that. When to use IVT versus MVT. So that's actually exactly what we're going to go over next. So it wouldn't have to reach 0, but the slopes would have to be the same. So I was using the slope definition of a derivative and saying that h approaches 0, where h is like the difference between your points. Basically, your slopes have to be the same is the best way to put how to make something differentiable. Okay, so next what we're going to do is I'm going to show you a problem, and it's you guys in the chat, you have to name which theorem it is and how, well, we'll just start with which theorem it is, okay? So then we'll go on to how do you know. Okay, so this is number 1. Take your time, read it, and then in the chat, see if you can take a shot at which theorem this is. All right, awesome. You guys are doing great. Okay, great. And yeah, so everyone who's answered so far has been correct. It is the mean value theorem. And Rashika gave us an answer here because it mentions derivatives. Yes. There's a few clues here to why this is the mean value theorem. It tells that it's continuous and differentiable. So it says both of those things. And also it mentions the derivative at the end. It says f prime of c. And so what would you want to do to solve this problem? Well, we're actually going to see that later when we're going to solve this in a free response question. So you'll see exactly how we would go about solving this question. But this is mean value theorem. Any questions? Did anyone not recognize this is mean value theorem and want more explanation as to why? Okay, we'll go to the next one. Okay, remember your choices are mean value theorem, intermediate value theorem, and extreme value theorem. Okay, you guys are doing great here. Awesome. Yes, this is the intermediate value theorem. Yes, so it mentions an interval. It's continuous on the interval. And then it gives you 2 x values and 2 y values. And then it tells you the y value. It says that there must be a value c where f of c is 3. So it tells you that 3 is the y value. And if you look at your two values here, you have f of 2 is, or f of negative 2 and 5, and f of 5 is negative 2. If 3 is in between those, you can use the intermediate value theorem. So it is important that you recognize that 3 is in between the 2 different endpoints. Okay? Yeah, so why is this the intermediate value theorem? So the way we know this is intermediate value theorem is because it gave us 2 y values. It gave us f of a and f of b. And then it told us that there must be some x value that exists when you plug in that x value, you get a value of 3. And that has to be true And actually, let's go back and look at the intermediate value theorem again. Okay, so it told us that let's apply our example to this. It's telling us that f of a, let's call that f of well, the graph that it gave us was more of a decreasing function, but we'll call f of a f of 5 at -2, and f of b would be f of 2 at this other point here. And it's saying that if you have 3, so k is 3, is there some value c, some x value that exists in that interval? So yes, there has to be a value of x that when you plug it in, you get 3, since this function is continuous and there's no breaks. So if there's no breaks, then there's no way that you would have a y value that's in between -2 and 5 that didn't have an x value with it. Okay, I hope that helped. I know it's kind of hard to just hear calculus. So for this problem, let's go back. Let me check. Okay, this one. So for this problem, the justification would be, it already told you it's continuous and differentiable. So I would say, since f is continuous and differentiable, by the intermediate value theorem, there must exist a value c. Oh, sorry, am I on the wrong one? Yeah, there we go. Okay, so by the intermediate value theorem, there must exist some value c at 3. And these ones are set up in such a way that there's not really a question being asked in them. But really, as long as you say, because it's continuous, then you can say by the intermediate value theorem. And as long as you mention that the y value, 3, is in between the two other y values, -2 and 5. I would also mention that. Okay, next. What do we think? I like your thinking, Rashika. Yes, good job, you guys. This is the EVT. Awesome. How did you know it was the EVT? Extreme value theorem. How did you know? Okay. It gave endpoints. Yeah, so that greater than, that's a really good clue that it's the extreme value theorem, because otherwise we're not really talking about anything being greater than or less than in any of the other theorems. Good, yeah, so one of the things with this is you might not think about the extreme value theorem if you saw this before, but if you see a problem like this where it tells you a function's continuous and it gives you endpoints and then it asks you to show something's greater than it, there's a good chance it wants you to use the extreme value theorem. So yes, by the extreme value theorem, there does exist a value c that works with this. Good job. Awesome. Okay, I've got a few more, so let's keep going. What do we have here? Okay, good. Yes. So why IVT? Exactly. Awesome. These are great explanations. These are great explanations. If your points switch from negative to positive, then you must have hit 0 on the way. And that's really what the intermediate value theorem is telling you, that you know. So there must be some x value where you hit 0. It looks like I accidentally wrote EVT for this one, but you guys are right. It is the intermediate value theorem, so ignore that. I'm just going to move on to the next one so we don't get confused by that. Okay. What do we think? The answers are coming in faster and faster. So, okay, awesome. You guys are doing great. So mean value theorem is correct. Let's talk again about why. So it says it's differentiable. Is it continuous? Yes, if something's differentiable, it's automatically continuous. Exactly, it's implied. So AP in your explanation may be looking for you to say, because it's differentiable, f of x is also continuous, to show that you understand differentiability and continuity. Yep, we can go over something like that. Okay, Rashika, can you ask your question with a little more detail? If there's what kind of limits? Oh, okay, yes. Okay, so if you have differentiability, then you definitely have continuity. So differentiable implies continuity. But if you have continuity, you can't necessarily say it's differentiable. And that's, yeah, one-way street, exactly. So that's kind of where the absolute value function comes in. Whenever I think of this, I think of the absolute value function, because the absolute value function is continuous, but it has a corner. And so then it's no longer differentiable because it has a corner. So then I know that if it's continuous, it's not necessarily differentiable, but that it can go the other way. So differentiable, yes, continuous, but continuous, not necessarily differentiable. It could be, but you have to prove it a little bit more. Yeah. Okay, next one. I think you guys are reading the first word and knowing which one. Yes, Perla, that's a good description. Okay, good. Yeah. Another clue, just something I've thought of as we're going here, another clue to when to use an existence theorem is if it tells you to prove that something exists. So if it says prove something exists, then you probably have to use an existence theorem. So we've had a couple intermediate value theorems, a lot of mean value theorems. This is the mean value theorem. And yes, it's because it's talking about differentiability, and it says there's at least one critical point. And when you hear the word critical point, you know it's talking about what function. If f is our function, the critical point is the first derivative, right? So if you hear critical point, it's talking about the first derivative. Awesome. And so that means we're talking about the mean value theorem here. Good. Great job. Okay. Let's apply it a little bit more. If I drove my car, no, the first derivative, that's a good question, Perla. I'll look into that, but no, not necessarily, unless it was asking you about an absolute max or min. Okay, I'm getting a lot of IVT here, and I'm going to actually challenge you guys a little bit here. And agree with, I'm not sure how to pronounce your name, but I'm going to go with what Segev just said. It is actually the mean value theorem. So let's think about why it's the mean value theorem. Okay, good. Yeah, so we're talking about speed, and we're talking about an instant where you're going 50 miles per hour. And if you're going 200 miles over 4 hours, your average speed over 4 hours would be 50. Okay, so you've got 200 miles over 4 hours is an average speed of 50. And then there's at least one point where you're going exactly 50. So that's saying, is my instantaneous rate of change the same ever as my average rate of change? Yeah, if we were talking about miles here, it would be the intermediate value theorem. If it said that you went from 1 mile to 100 miles, and it said at one point you hit 50 miles, that's the intermediate value theorem. But yeah, since we're talking about a rate right now, we're talking about the mean value theorem. Okay, so you want to think about mean value theorem as always having to do with a mean or an average. So in this case, what the mean value theorem tells us is that the average rate of change at some point is equal to the instantaneous rate of change. Okay, so in this case, it's telling us that is it true that at least one point in time we're going 50 miles per hour? So that's our instantaneous rate of change, okay? 50 miles per hour, we know it's a rate because of what it's because of the units, miles per hour. And then it tells us we're going 200 miles over a period of 4 hours. So if I just gave you that information, 200 miles over 4 hours, and I said, what's your average rate of change, how fast you're going on average, you would take 200 and divide it by 4, and you'd get 50. So if your average rate of change is 50 and your instantaneous is 50, that's saying that your average rate of change is equal to your instantaneous rate of change. And that's what the mean value theorem tells us. So that's a good question, Perla. I think it's assumed that you just drove 200 miles for 4 hours. So it's 0 to 200 for your endpoints, and for your X, it's 0 to 4. But that's a good question. You're welcome. No problem. All right. In an applied situation like this, Perla, yes. I think what Perla was saying was, do we have all of the conditions we need? And in this case, we do have all the conditions because of the real world application that's happening with it. So this would not be intermediate value theorem. Okay. Let's look at this next one. Continuous and differentiable. You're catching on. Yeah, so it says tangent line, so that tells us a little clue about which one it's talking about. So you guys like tangent. Tangent helps you know which one to use. Awesome. Yeah, so continuous and differentiable is one clue that you need the mean value theorem. Tangent line is another clue. Exactly. So you guys are getting this. And it says parallel. So when you see the word parallel, what do you know about parallel lines? They have the same slope. Exactly. So if they have the same slope, that means we're talking about the mean value theorem. We're talking about something with a slope. Awesome. Great job, you guys. Okay, just 2 more of these, and then we're going to actually practice a question. A full question. Okay, f of x is continuous on a closed interval. Then there must be a maximum. I think that's the fastest the answers have come in so far. Yes, great job. It literally directly says maximum and minimum. Yep, then you're good. It's the extreme value theorem. Perfect, great job. All right, let's finish this off with one last one. Let me get ready to give you guys that question. You see F prime, good. Yeah, mean value theorem, awesome, you guys. So this one's really similar to the first one we did. It's just another review because we're actually going into a problem that uses this. So good, mean value theorem. All right, I'm going to give you guys a second to look at the problem we're going to do, and then I'm going to start doing it out in a notebook. So if you guys want to get a notebook, you do not need your calculator for this question. This is a question 6 of a free response question. But this is what we're going to be doing today. And 3 of the 4 parts of this require a theorem, an existence theorem. So just take a look at that question while I get ready over here. Okay, we've got 4 parts. We've got a function that depends on another function. Okay, I'm going to stop sharing this so you won't see the question anymore. If you want to look it up, it's 2007 Form B. Yes, twice differentiable means you can find F double prime. Okay, and yep, you'll see the question again in a second. I just need to switch over screens. Hi again, everybody. Let me share something else with you. Okay. All right, can everyone see that screen pretty well? No. What is wrong with it? It's small. Okay, I just made it pretty big. I'm not sure why it's small. Is the problem small or the screen? Okay, I can make the problem bigger. Is that better? Okay. Okay, so we're going to have to scroll through this a little bit. We might not be able to tell me to see it the whole time. Sorry, I was reading one of your messages as you're going through. Okay, so let's start with part A here. So we've got a twice differentiable function. We've got some information about that function at 2 different points. And we've got another function that's in terms of that function f, and that's g. So part A says, explain why there must be a value c, c being between 2 and 5, such that f prime of c is -1. What do we think? How do we want to start this off? Oh, okay. You're already seeing the mean value theorem. Awesome. Okay. So we know it's the mean value theorem, but now we have to explain and actually explain why that's true. Okay. So the mean value theorem tells us, I'm going to start writing now. Hope you guys can read this as I write it. So we know that the mean value theorem tells us that if we have 2 points A and B, that f of B minus f of A over B minus A should be equal to f prime of C. Okay, so according to the information we have, Rashika, exactly. Yes, so we do want to talk about that. It states that it's differentiable and continuous. So we know that f is differentiable and continuous. So that means we can use the mean value theorem. But it wants us to show, how do we know that it can work at -1? Well, it's actually exactly what Rashika wrote. So if we've got f of 5 minus f of 2 over 5 minus 2, we end up with 2 minus 5 over 5 minus 2, which is -1. So in this case, by MVT, mean value theorem, since f of, and see, I would write it, I'm going to write it all out just to make sure we have the practice with writing it all out, is -1, there has to exist, and sorry, I'm going to have to scroll up now. There has to exist a point C where f prime of C is -1. Okay, so that's a good explanation of that first part here. So yes, so if it told us, so if that problem had said, explain why there must be a value C between 2 and 5 such that f prime of C is 3, we couldn't have done it, because we don't have any information that tells us that there's a value between the 2 points we're given that would give us 3 as an average slope. So you still need to prove that you can get -1 using the average slope. But then since it's differentiable and continuous, you already know that there must be an instantaneous slope or a derivative at -1. Yes, Perla, I think that would be good enough, as long as I think it's really important that you make sure to show that this step is true, okay? You need to actually do the math for at least one side of the mean value theorem to show that it could equal the other side. Okay, any more questions on part A? Okay. Okay, let's go to part 2. Thank you, Akshita. for your response. So part 2, we're going to have a little bit of deriving to do here. So let's talk about this. We want to show that G prime of 2 equals G prime of 5. And then it says, use this result to explain why there must be a value K in between 2 and 5 such that G double prime of K equals 0. Yes, chain rule. We are definitely going to need chain rule. We're talking about G prime, and then it's having us find something about G double prime. So what relationship is that? Reading this, do we know what theorem we might need to use to explain? So it's actually still the mean value theorem. And while it is between a derivative and its second derivative, it's still like one function to its derivative. So as long as it's going like one step away in derivative, you can use the mean value theorem. So the mean value theorem still applies here. Yeah, in this case, it's actually Rolle's theorem, which is a subset of the mean value theorem because it's talking about 0, but saying mean value theorem is more than okay. You don't worry about Rolle's theorem. That's like it's a specific set of mean value theorem where it just equals 0, but mean value theorem works. So all you have to use is mean value theorem. Okay, so in this case, what do we have to start by doing here? What do we need to find? All right, we're getting lower on time, so I'm just going to go for it. We need to find G prime here. Okay, good. Thank you, Rashika. Yeah, exactly. So the responses are coming in now. So we know what G of X is. We know that G of X is F of X. So we need to find G prime here. So G prime is going to be, yes, chain rule is correct. So it's going to be F prime, and feel free to check me on this, make sure my math is correct. F prime of X times F prime of X. Yes? Are we good with that? Yeah, okay, awesome. And then it says find G prime of 2 and G prime of 5. Okay, so G prime of 2 is going to be F prime of F of 2 times F prime of 2. Okay, and I can simplify this a little bit because I know what F of 2 is, so I can make this F prime of 5 because F of 2 is 5 times F prime of 2. Okay, I think that's as far as I can go right now. We'll see if any more information comes up. Let's do G prime of 5. We're going to get F prime of F of 5 times F prime of 5. Well, F of 5 is 2, so we can plug in F prime of 2 times F prime of 5. Well, according to rules of multiplication, those are equal, right? Because they're both F prime of 2 times F prime of 5. They're just written in a different order. So we have proved that G prime of 2 equals G prime of 5. We've shown that because we've found them both. We might not know the derivatives of F, but we can at least show that they're the derivative at 2 and the derivative at 5 are just going to be multiplied together. So it doesn't matter really which order they're in. Okay. And then it says use this to show that to explain that G double prime of K equals 0. How does this help us know that G double prime of K can be 0? Yeah, well, mean value theorem. So we have to think of how can we apply the mean value theorem here, but we're kind of using it a step down. So instead of G of 2 or G of 5 minus G of 2, I need to do G prime of 5 minus G prime of 2 over 5 minus 2. And, well, if we have G prime of 5 minus G prime of 2, what are we going to get? 0, exactly, because G prime of 5 and G prime of 2 are the exact same. So we get 0. So by the mean value theorem, since G prime of 5 minus G prime of 2 over 5 minus 2 equals 0, then then there exists a K such that F prime of K equals 0. And that's because of the mean value theorem. One thing I did not state here, but I probably should have, is that, again, G is differentiable and continuous. How do we know that? How do we know that G is differentiable and continuous? Yeah, it's somewhat given. So I would say because G is made from F, and F is differentiable and continuous. Okay, so that's your full explanation there. Yes, G double prime, thank you. This should be G double prime. Good catch, Morgan, thank you. Okay, so make sure you fix that in your notes if you took notes. I used the wrong notation here, so we found the average rate of change of the derivative, and that says that G double prime of K is going to be 0. Thank you for that catch. Okay, let's move on to the next part. So you can't see it anymore. Let's scroll up and look at it for a second, and then we'll come back. Show that if F double prime, so I'm going to start you off just so you're not looking for a theorem here. This part does not include a theorem. So not every single part of this problem has a theorem in it. This is the one part that does not. So we've used the mean value theorem twice. This one says, show that if F double prime equals 0 for all X, then the graph of G does not have a point of inflection. Okay, so now we're applying something we haven't really talked about today, but still a good thing to apply. So let me just summarize down here for you. Let me make some space here. So this is part C, and it says, show that if F double prime of X equals 0 for all X, then G does not have a point of inflection. Okay, I see a response here. So it's 0, then F double prime doesn't change, it's constant, so no inflection. Exactly. So that's exactly right. Basically, if F double prime is 0, then there's no inflection points, because that means that F double prime is constant. That's a good question, Perla. I've never seen that abbreviation. I would maybe ask your teacher, but I've never seen that for an abbreviation. Okay. I see a couple questions. I'll go to those in the end. Which abbreviations are acceptable? That's actually a really good question, and I don't know. I would say, in general, always write everything out. That would be my, besides the theorems are accepted as far as I know. But honestly, even with those, I'm actually, you know what? I'll look at a scoring guideline right now, and I'll let you know. So give me 1 second. Okay, so I'm looking at this question actually, and it looks like in their description, they actually completely even write out the theorem names. So I would say don't use any abbreviations. I would say write everything out just to be absolutely sure. Okay, so no abbreviations. Okay. Okay, so for the justification for C or for part B? C. Okay, yeah, we're not done with C. We actually need a lot more explanation than what we've given so far. No worries. Yeah. So you guys have given some good explanation. So we know inflection points. And this is actually a point that we need to make sure we have. Inflection points, they happen when f double prime of x changes sign. Okay, so just because f double prime of x is 0 doesn't necessarily mean you have an inflection point. Okay, yeah, so Anika, that's actually not exactly enough. It needs to change sign. So it needs to go through 0 and it needs to go to the other side. So if for some reason your second derivative looks something like this, that wouldn't be an inflection point because it doesn't change sign or go to the other side of the axis. Okay, so your f double prime of x needs to change from positive to negative or from negative to positive in order for you to have an inflection point on f. Okay, so we want f double prime of x to equal 0. And if it equals 0 for all x, let me just erase this graph, give a little bit better description here. If it equals 0 for all x, then we just end up with this, this like straight line for f double prime. So there's not going to be an inflection point because we never change sign. F double prime of x is never changing sign. But we have to prove this. So we can't just say, well, if it's 0, it's never changing sign, but we have to prove that our f double prime will be 0. Yes, Akshita, that's true. Yeah, good. Okay, so we have to prove f double prime of x is 0. So we need to find f double prime of x. So here we go. Let's remember what's f prime right now. F prime of x was f prime of f of x times f prime of x. We use the chain rule. And what are we going to have to use here? What derivative rule? Chain and something else, actually. Product rule, exactly. Chain and product rule. We're going to need to use those both. So this is not really a pretty one. And this is actually a really good example of the fact that a bunch of different units can be in the same section. So chain rule and product rule are in one section, but points of inflection are in a very different unit. So it could be anything. I think we're talking about, no, this is f prime of x, and we're going to try to find f double prime of x right now. Yeah, because it says show, it said show, I didn't write that word, show that f double prime of x equals 0. Okay, so f double prime of x, to save some time since we're almost done, I'm going to tell you what it is, just to make sure we get it right on the first try, because it's kind of big because we need to use product rule and chain rule. So f double prime of x is f double prime of f of x times f prime of x times f prime of x. Yes, plus f prime of f of x times f double prime of x. Okay. So this is our second derivative. And then it said show that if f double prime of x, yeah, it is ugly, I agree. If f double prime of x equals 0 for all x, then g does not have a point of inflection. So this is really important here. F double prime of x equals 0. So that means that this value is 0 and this value is 0, right? You'd think f double prime of x would just be f double prime of x, but it's not. That's a good question. Okay, so these are both going to be 0. Okay, and when we get 0 for both of these, we're just going to get 0 plus 0, which means that f double prime of x is 0. Okay, and if f double prime of x is 0, then there we go. We've proven it. Yeah, so well, actually, let's take this a little bit further. I think, Maria, you might have been right. We needed to look at G double prime. Then the graph of G. So it said show that if f double prime of x equals 0, then the graph of G does not have a point of inflection. So this is G double prime. My bad. Sorry. So this F double prime of X equals 0, but this is G double prime, and this is G prime, and that's why it seemed different. Yeah, so we did find G double prime. My bad there. So let's go back and summarize what we did here. Show that if F double prime of X equals 0, then G does not have a point of inflection. So if G doesn't have a point of inflection, that means that G double prime of X never changes sign. Never changes sign. Okay, so G double prime of X is never changing sign. So then we find G double prime of X, and we use the fact that F double prime of X is 0 to get that G double prime of X equals 0. Yeah, sorry, Maria. That was a good point there. I missed that. That's why you should always have the problem in front of you while you're doing the work. So we do need to use and plug in F into G prime, and it makes a lot more sense. F double prime of X should just equal F double prime of X, and that should have been a tip off for me too. So you guys are in a good place right now. You're catching that already. All right, let's do that last part D, and then we'll finish it up there. Okay, so let's take a look at what part D says. Let H of X equal F of X minus X, and explain why there must be a value R between 2 and 5 such that H of R equals 0. Okay, what theorem is this? Yeah, this is going to be the IVT. Okay, so we need to do a little bit more explanation to show exactly why it's the IVT, but this will be the IVT. Okay, so I'm going to write down what we need down here and hopefully not confuse myself by not being able to look at it. But it's, let's draw a line. H of X is F of X minus X. Okay. And then we are told that explain why there must be a value R and R is between 2 and 5 such that H of R equals 0. Okay, so if we're saying that this is true, then we need to prove that okay, yeah, so good, Rashika, that's exactly. We need to prove that H of 2 and H of 5 are on opposite sides of 0. Okay, so we need to show that there are two different, that we at least have to have 0 in between our numbers. So how can we do that? Yeah, you plug in. So, okay, so H of 2 is F of 2 minus 2, which if you don't remember from above, F of 2 is 5. So we get 3. H of 5 is going to be F of 5 minus 5, which is going to be 2 minus 5, which is negative 3. Okay, so we've got two things here. We've got H of 2 is 3. We've got H of 5 is negative 3. How do those two values help us? Awesome. One's positive, one negative, so 0 has to be in between them. Exactly. So, so H of X is continuous, right? Because we know that F is differentiable. Because F is differentiable. F is differentiable. Okay, so by the intermediate value theorem, I'm going to write it all the way out for you guys. You can tell I was meant to write numbers and not letters. By the intermediate value theorem, H of R equals 0 at some point. R between 2 and 5. Okay. Yeah, I'm also glad about the grammar part that I'm not really required to have it, but I guess in laying I don't really know. I didn't take that. Yeah, let's explain our procedure in Part D. Okay, so let's just take a look. Let's focus in on this. So we were told this is h of x, and we were told to explain how there has to be an r value between 2 and 5 that would make h of r 0. So the only way we can know that to be true is by using the intermediate value theorem. And hopefully it works out that we know values that are either less than 0 and greater than 0 to show that we have something in between. So we start by finding what we know about the endpoints. So we want to use these two endpoints that it's given us and plug them into the function it's given us here. Okay. I'll answer your question in a second, Anika. So we've got h of x here. We know our endpoints are 2 and 5. If we plug in 2 and 5, h of 2 and h of 5, we get 3 and negative 3. Good so far? Good. Okay. So we know that h of 2 and h of 5, if I were to graph this, I know that h of 2, actually, I'll make that a little bit higher, just a little zoomed in. We know that h of 2 is going to be up here somewhere. And we know that, so let's say that this is 2. H of 2 is at 3 here, up here at 3. And then h of 5, this is 5 over here, is down here at negative 3. Okay, and so we know that this is continuous, which means that these have to connect. Okay, since they have to connect, there is no way for these to connect without it crossing through 0. Okay, if it crosses through 0, that means there has to be some x value here. Let's call it r. That's between 2 and 5. It's between 2 and 5, and that allows us to say that there is some value h of r that's going to give us a 0 as an h of r to be 0. There's some r value that gives us that. And it has to happen because of the intermediate value theorem. Yes, you have to use the y values to find it. You're welcome. Can you still use the IVT if the derivative is not the mean? I'm not sure what you mean, Anika. Can you still use the intermediate value theorem if the derivative is not the mean? Do you mean the mean value theorem? Can you still use the mean value theorem? Okay, no. So if you're going back to like part 1, if we had done out the average slope, the average derivative, and it wasn't the value it wanted us to find, then we couldn't use the mean value theorem. Okay, so I'm going to scroll up a little bit to talk about that for a second. Okay, so it told us to find that f prime of c equals -1. Okay, so if you were to find the average rate of change, if you were to find the average here, and the average did not equal -1, then you couldn't prove anything with that. It needs to equal -1 in order for us to use the mean value theorem. I would say the more time you spend, the better. I think that prepping AP sessions, if you're coming every week, would be good. But I do think it's good to practice more than once a week if possible. But yes, our sessions, and even if you're logging on maybe halfway through the week and looking at an old one of our sessions, using all of our sessions should be good enough to prep you. We also have study guides and some trivia questions for you. Okay. All right, so that's this problem. It used the mean value theorem twice and the intermediate value theorem once. We didn't get to use the extreme value theorem in this question, but using the extreme value theorem, again, when that popped up in those questions, you kind of knew exactly when you needed to use it. And really, you just have to state that it's continuous and state you can use the extreme value theorem. Sorry we went a little over, but I hope you found this helpful, and I hope you got all of your questions answered. I have some questions in the thing. If you want to check out now, feel free. I am going to look at these questions. So thank you guys. Awesome. I'm glad it was helpful. Will it be open note? Yes, it will be open note. You can use anything you want. That would be that's a great idea, Perla, about do you recommend having a page of theorems? I think that's a great idea. Absolutely. A page of theorems next to you would be an awesome thing. Even a page, if you look up on the internet, theorems you need to know for AP Calculus, you'll find full sheets of all the derivatives you need to know, every theorem. Yeah. I would say anything that you need to save your time, but it's really important that you can recognize using the theorems. But anything that would have been memorization, anything that would have been memorization, I would keep right next to you, so that you have access to that pretty quickly and you don't have to look it up. But if you type into the computer, like, things you need to know for the AP Calculus exam, it should give you a list of derivatives and integrals you should memorize, theorems you should know. And that would be a great thing to have next to you during it. So does the limit exist? That'll be in a different, questions about does the limit exist? Is this continuous and differentiable? That will be a different stream, but we definitely can go over that. So if you want to go over questions about continuity and differentiability, feel free to please keep looking for it in future streams, because we can definitely go over that. I'll talk to the other AP teachers and we can look at that. You guys did, yes, that would be like basically unit 1, some of unit 2, I believe. Yes. Yeah. So thank you, Akshita. So if you look back, I think I actually did one maybe back in September on limits and continuity that might be helpful to you, that you should have access to. That was when I was first starting, though, so sorry. I probably am a little bit better now. I don't know how I looked back then. All right, awesome. Thank you, guys. You were great. You did a great job. This will be up on Fiveable by later tonight, so you guys can check it out. And yeah, feel free to reach out with any questions or any kind of streams that you want to see. We're happy to do whatever you want to see, but every Monday you've got AP Calculus question and answer and some specific content. Oh, thank you very much. I really appreciate it. You guys have a great night. You're an awesome, awesome class. So thank you very much. Thank you. Thank you. Great job, everybody.